With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there is a body of mass m which is suspended from the vertical spring and set into simple harmonic motion of time period capital T. Now next, the spring is fixed at one of the end on a smooth horizontal table. So initially it was the vertical and now it is horizontal motion. And same body is attached to the other end. The body is pulled slightly and then released to produce horizontal oscillation of the spring. Now the time period of the horizontal oscillation would be equals to what? Okay, whether t or 2t or t by 2 or infinite, as the spring does not oscillate. Now, so we know that a spring would oscillate. So this D option would be the wrong option. Now, for example, for the this vertical part, if you just draw, so we take, let's say this is the situation, and here we are having a ball, or we can say that there is a mass which is attached here. Mass is m. Okay. Now this is our spring. This is our spring. Now what will happen due to our mass? This spring would be stretched slightly downward. Now it would be, this is the, let's say, new position in the equilibrium condition. This is our mass m. Okay. Now there would be an extension. Let's say this is the initial extension. We say that this value to be x naught. Okay. So our spring would be stretched slightly. Now what will happen? Now what we are doing, we need to perform the SHM. Now if we again make a small force, okay. Now this stretching is due to the weight of the body, which would be equals to, so m is the mass, so weight would be equals to mg. M is the mass, weight is equals to mg. So this would be the initial elongation. Now if we wanted to set this this body into SHM, we need to pull it, okay, either downward or upward. If we pull it in the downward direction, we are drawing for the downward case, so it would be extended by a small amount. Let's say we are just producing a small extension. Let's call the extension from this position. This would be our x, okay, and this is our initial position. So this is our x naught, okay. Now from the first case, from the second case, if we see, so mg and this kx, they would be in the equilibrium condition. So we can say that mg would be equals to k into x naught. So this is the weight and this is our this is spring force, okay. Let's say this is our equation 1. Now in the second case, we say that mg, again there would be mg. First of all, we just write the net force. So the net force, if we write in the second case, because there would be some acceleration into this case. Why? Because we have stretched this string, spring. This is our spring. So this will be pulled back. Okay, it would be pulled back. So due to this, there would be an oscillation here. So we say that there would be an acceleration also. So the net force which would be acting here, it would be the spring force. We say that it would be k total extension, which is equals to x plus x naught, minus downward force would be equals to mg minus mg. This would be mass into acceleration. Now from here we can see that mg value is equals to kx naught. If we put the value of mg as kx naught, so here the factor of kx naught would be cancelled, and the only thing which would remain would be equals to kx equals to ma, or we can say that our acceleration would be equals to k by m times x. Now if we compare this with our equation a equals to omega square x, we can say that our omega would be equals to under root k by m. Now if this is omega, what would be the time period? In the vertical case, it would be 2 pi by omega, which would be equals to 2 pi divided by m divided by k. Now this is a formula which we should also remember. Now in the second case, what we are doing? Now in the second case, we are fixing the string, this is spring, and we are performing, this is performing a horizontal motion. So we just draw, let's say this is our body and the mass is same. We have made it to be exaggerated, but mass is essentially the same. This is our spring. Okay, now from the mean position, this could be the mean position. If we just stretch the spring further, or if we move the object further into this direction, so there would be a spring force which would be acting in the opposite direction. Now mg would be acting in the vertical direction, normal reaction would also be acting in the vertical direction. So there is no component of mg or normal reaction in the horizontal direction. So what is the only force in the horizontal direction for this mass? It is just equals to our spring force. So we can say that our net force would be just equals to our spring force kx. We can say that net force value would be equals to mass into acceleration. This would be equals to k into x. Then acceleration would be k divided by m into x, which we can put it equals to omega square x. Now from this expression and from this expression, we can see that omega value is still the same. Omega value, if we just calculate the value of omega, it would be equals to k divided by m. Now if we mark this as our omega 1, this mark as time period 1, this mark as omega 2, and this mark as time period 2. Time period 2 would be equals to 2 pi divided by omega, which would be m divided by k in the square root. Clearly we can see that T1 and T2 both are equal. We can say that our T1, or we can say that T2 would be equals to T1, and T1 is given as to be T. So we can see that new time period is equals to the initial time period. So the correct option would be our A option. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.